Hey, Algebra 2. So this will go over the RAD 3 homework as well as the RAD 4 lesson. Hope you're all doing well. First problem, so square root of 16 is 4, square root of 25 is 5, and there's your answer. Those are perfect squares. Number 2, square root of 100 is 10, square root of 81 is 9. Both perfect squares, made it nice. These are also both perfect squares. Square root of 49 is 7, square root of k squared is just k. This is perfect square because that's even, so 2 goes into 10 5 times, and square root of 121 is 11. Now we're into third roots, and these are both perfect third roots. 4 times 4 times 4 is 64, so the third root of 64 is 4. Third root of x to the third, 3 goes into 3 once, so that's on top, on bottom. Third root of 27 is 3. 3 goes into 9 3 times. There's your answer. Let's see, we have 216 over 243. So you have to kind of think about your perfect cubes. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6, 7 times 7 times 7, 343. All right, so just by doing those, 216, so that's going to be 6 over 7 because cube root of 216 is 6, cube root of 343 is 7. Next problem, so we can break this up into a couple things. So the top uh, is going to break down. We're just looking for square roots. So I have 5 times 25 is 125, and then I have y squared and y. And x to the fourth is a perfect square, so we can do that. So square root of 25 is 5. Square root of y squared, 2 goes into 2 once. And that's all I can do on top. 2 goes into this 4 twice. And then I'm left with the square root of 5y. And I guess if you wanted to, you could put it all over like that, or, that's fine. Number 8, we're looking for perfect squares. So I know that 9 times 5 is 45. A to the fourth times a to the first is the same thing as a to the fifth. B to the sixth is the perfect square because it's even. So square root of 9 is 3. Square root of a to the fourth is a to the second. Square root of b to the sixth, 2 goes into 6 3 times. And then we have on top, it looks like a 5 and an a. There's your answer. We're looking for perfect third roots. So I'm going to break 16 into 8 times 2 because 2 times 2 times 2 is 8. That's a perfect cube. And then I'm going to make x to the fifth, x to the third, and x to the second. And then 27y to the third, those are all perfect cubes. So cube root of 8 is 2. Took care of that. Cube root of x to the third, 3 goes into 3 once. And then on the bottom, cube root of 27 is 3. Cube root of y to the third is y. And then I have left on top 2x squared. That was the third root. Number 10, third root of 64. Let's break this up a little bit. So 64 is a perfect cube, so let's leave that. And then I'm going to make that x to the sixth and x to the first. And then 125 is a perfect cube because 5 times 5 is 5. And y to the sixth is perfect because 3 goes into even one. Third root of 64 is 4. Third root of x to the sixth, 3 goes into 6 twice. And then I'm just left with third root of 1 on top. And on bottom, third root of 125 is 5. Third root of y to the sixth, 3 goes into 6 twice. Okay, we want to simplify each radical. And it says divide first. Okay, so let's reduce it first. So 3 goes into 27 9 times. A's cancel each other out, right? They're gone. So square root of 9 is just 3. Number 12, let's reduce it first. So 7 goes into 28 4 times. Tug of war with the y's. Top wins by 4. And then I have the square root of this. So square root of 4 is 2. Square root of y to the fourth 2 goes into 4 twice. There's our answer. On this one, they're both third roots, but 5 goes into 48 times. So I get third root of 8. Third root of 8, 8's perfect cube, so because that's 2 times 2 times 2. Number 14, 5 goes in 125 25 times. Tug of war with the x's, they cancel each other out. And then I'm going to change y to the third to the y to the second y. Then I have square root of 25 is 5. Square root of y squared is y. And then I have a root y at the end. Let's see, 7 goes into 56 8 times. Tug of war with the a's, top wins by 2. And then that's a perfect square. That's what we want. And then I'm going to change b to the third to b to the second, b to the first. 8's the same thing as 4 times 2. So I'm going to go square root of 4 is 2. Square root of a squared is a. Square root of b squared is b. And then I have square root. I have this 2 still left behind and b. There's our answer. Let's see. We can reduce this a little bit. Let's see. 96 over 12. What number goes into both? 6 goes into both, so 6 goes into 90 once, 16 times, and then over 2. Oh, that's going to, 12 would have went into there, so I'm just going to forget about that. So I have third root of 8 on top. Tug of war with the C's, top wins by 2. Tug of war with the D's, top wins by 2. So I'm going to get third root of 8, which is 2, and then all the rest stays behind because I don't have any perfect cubes amongst there. All right, let's see. I think 7 goes into 189, so we could reduce that. Just use a calculator. 189 divided by 7 is 27. So I have third root of 27 on top. Tug of war with the x's, top wins by 3. Oh, that's nice. That's perfect cube. Tug of war with the y's, I get y to the 5th. All right. So third root of 27 is 3. Third root of x to the third is x. I'm going to break y to the 5th down to y to the third, y to the second. So third root of y to the third is y. And then I'm left behind with third root of y squared. On this one, this 3 can go into 75. That's going to go in there 25 times. And then I have g to the 9th, which I'm going to make that g to the 8th and g to the 1st. All over 3. So square root of 25 is 5. Square root of g to the 8th. 2 goes in 8 4 times. Then I'm left with g under the radical. And I get a 3. All right, let's start reducing this down. So I have 4th root on top. 2 is under the radical, so 2 goes into 64 32 times. Tug of war with the r's, so I get r to the 4th. 2, 4, 8, 16. So I'm going to break 32 down to 2 times 16 and r to the 4th. And the reason I did that is a 4th root of 16 is 2. 4th root of r to the 4th, 4 goes into 4 once. And then I'm left with 4th root of 2. All right, so challenge, it says factor first. Okay, so you might remember the top is called the difference of 2 squares. So I'm going to get x plus 3 and x minus 3 all over root x plus 3. Well, the x plus 3's cancel each other out, so I'm just left with square root of x minus 3. That's kind of a, think about that one a little bit. Okay, let's take a look at RAD 4 notes. Okay, students will add, subtract, simplify radical expressions. All right, so let's go ahead and simplify these. Square root of 25 is 5. Square root of x squared, 2 goes into 2 once. Square root of 121 is 11. Square root of y to the 4th, 2 goes into 4 twice. Get that. Number 2, let's see, I'm going to reduce it first. 5 goes into 45 9 times. Tug of war with the x's, top wins by 2. Square root of 9 is 3. Square root of x squared is just x. And then they want us to combine like terms. Oh, this is a little turn. So same exponent, so that's 2x squared. And I have x and minus x. So 3x plus 5x is 8x. 8x minus 12x is minus 4x. While any two real numbers can be added or subtracted, radical expressions must have like radical terms. meaning they have the same nth root and letter, maybe? I don't know. For example, there's a good example. It's subtract, do not change the radicand. Okay. So if we add these, notice I have root 7 and root 7. So I'm just going to add the outside. So I get 12 root 7. This one I'm going to put a 1 there. Both the same radicals. So 5 minus 1 is 4. Root 3, notice the root didn't change. This one I have like terms. These are like terms. So 10 root 2 plus 7 root 2 is 17 root 2 minus 5 root 5. And you can't go any further because you don't have different radicals. All right, so I have square roots and I have third roots. So these can be combined together because they're same radical. So that's going to give me 9 root 5 plus, oops, actually it'll be a minus. Third root 5, so 4 minus 8, so negative 4, third root 5. It's done. Number 5, we have root 9, root 9, root 9, all third roots. So 8 minus 7 is 1. 1 plus 5 is 4, so I get 5 third root of 9. Again, those are all the same root. There's a 1 out in front of that, so I'm going to get 6 plus 4 is 10, minus 1 is 9. 9 fifth root of 4x. So when we subtract them, so things we need to look at. I have 5 root 3, which is great. 12 breaks down to 4 times 3, so square root of 4 is 2, so that becomes 2 root 3. Now they're the same radicals, I can go ahead and subtract, so 5 minus 2 is 3, so I get 3 root 3. So let's keep going. I want to break root 8 down. I'm going to break that to 4 times 2 minus 5 root 2. Square root of 4 is 2. 2 times this is 6, so I get 6 root 2 minus 5 root 2. 6 minus 5 is 1, so 1 root 2, or you could have just root 2. Doesn't matter how you put your answer either way. 28 is going to break down to 4 times 7. 4 is the biggest perfect square in there. So square root of 4 is 2. 2 times the outside 4 is 8, so I get 8 root 7 minus 5 root 7. 8 minus 5 is 3, square root 7. Now we're looking for perfect thirds. So think about 24. 24 is the same thing as 8 times 3, and 8 is a perfect cube. So the cube root of 8 is 2. 2 times the outside 10 is 20. So I get 20 third root of 3 minus 1 third root of 3. Same radicals, so we can subtract them. 20 minus 1 is 19. So 19 third root of 3. We want to start breaking down. We want perfect thirds. So y to the fifth is y to the third times y to the second plus 2y third root of y to the second. This is a perfect cube. Cube root of y to the third. 3 goes into itself once. So I'm going to get 4y outside. And I get third root of y squared plus 2y third root of y squared. Radicals are same. Looks good. So 4y plus 2y is 6y. Third root y squared is our answer. Looks like we want third root, so I'm going to break 16 down to 8 times 2. I'm going to break y to the fourth down to y to the third times y to the first, plus 7 third root of 2y. So third root of 8 is 2. 2 times the outside 5 is 10. Third root of y to the third is just y. And then I'm left with third root of 2y plus 7 third root 2y. 10 plus 7 is 17. Actually, there's nothing I can do. That's our answer because I have a 10y plus 7. So that's as far as I can go. Cool. All right, last example. So I get 3. I want perfect fourth roots. So 32 is 2 to the fifth because 2 times 2 times 2 times 2 is 16. That's a perfect fourth times 2. Then I'm going to break x to the fifth to x to the fourth, x to the first, plus 5x fourth root of 2x. All right, fourth root of 16 is 2. 2 times the outside is 3 is 6. Fourth root of x to the fourth is just x. And then I have fourth root of 2x plus 5x, fourth root of 2x. Everything's like terms, so go ahead and add them. 6x plus 5x is 11x, fourth root of 2x. All right, if you would, let's take a look at this. Looks like a few of them they're trying to work out for you. So focus on trying to get this worksheet, a good try for the whole thing. And then it looks like we have a review. That'll be on the next day. And then so we should be having a quiz coming up. So have a great day. But take a look at working on worksheet RAD 4. Take care of one another.